Hey everyone, I wanted to go over the naming of these ionic compounds from lecture that we didn't get to do in class. So I'm going to start with A. The first thing you want to do is identify your cation, which is always the first element written, and then the anion, which is always the second element written. Okay, so manganese is our cation here, and you want to decide, is your cation a main group cation or a transition metal cation, because that's going to change how you name it and whether you need Roman numerals or not. Remember, you only need Roman numerals if your cation is a transition metal cation. And here, ours is. So we will need Roman numerals when we write the name of this, okay? So now I'm going to write manganese. And then I'm going to put the charge of manganese in Roman numerals. An important thing to remember is that the number for your cation, whatever the number is, plus the number for your anion, those have to add up to equal 0. This has to be a charge-neutral compound overall. All right, so just keep that in mind as we figure out what the charge is. Now, because manganese is a transition metal, we don't automatically know what its charge is. Remember, transition metals can form different cations with various charges, like a +2 or a +3 or even up to a +4. So what I like to do is split my compound in half, and I like to look at my anion side first. Okay, now I have a subscript of 2 here, but that does not mean the charge on fluorine is 2. Okay, fluorine is a main group element, and we said there are predictable charges for pretty much all the main group elements. So fluorine is in main group 7. It has 7 valence electrons, and we know all the halogens in main group 7 form anions with a -1 charge. Okay, this should be in your lecture notes earlier on in chapter 3. Now, because I have 2 of them, that means I have -1 times 2. All right, so the total amount of negative charge for my anions is a -2. And so whatever the total amount of positive charge for my cations is, plus my anion charge, remember this has to add up to 0. Okay, so now manganese is on the other side, and I only have 1 manganese cation. How do I know that I just have 1? I don't have a subscript here of anything. I just have an understanding of 1 manganese because I don't have a subscript of 2 or 3. If you just have the chemical symbol written, you just have 1 of that cation. So I know it has to be a +2 for this to add up to 0. All right, now that I know the charge on manganese, I'm going to indicate that it's a +2 with my Roman numeral of 2, and then I'm going to finish with fluoride. IDE. Okay, so the name for this compound would be manganese 2 fluoride. I would encourage you to try these on your own, the rest of these, and then pause this video and see if you get them right before you just watch me do them all. It'll be more beneficial for you to try them first. Going down to the next one, again, here is my cation, aluminum. You want to check, is it main group or is it a transition metal? Well, aluminum is in main group 3, so I know that this cation carries a +3 charge. Remember, the subscript does not mean aluminum is a +2. The subscript is just telling you how many of your aluminum +3 cations you have, okay? And then I know oxygen is a -2, okay? Now, again, you can make sure these add up to 0 overall because I have 2 aluminum +3 cations and 3 oxide anions. Both sides are going to add up to 6, okay? The aluminum side, this is going to add up to a +6, and the anion side is a -6. So this is definitely a neutral compound overall. And I won't give you a formula if I'm asking you to write the name. That's not a neutral compound on the exam, okay? That would be a typo or an error on my end. But anyways, we don't have to do really all this math. All we're going to write is the name of this compound, aluminum. Whoops. And then oxide. We don't have to do all this math because we already know the charge on aluminum, and so we don't need to indicate it anyways in the name. We don't need Roman numerals because, again, aluminum's not a transition metal. So aluminum oxide is the name there. Okay. Now, again, looking at the next one down, see, Ti is titanium, and that is a transition metal. So here we are going to need to figure out what the charge on titanium is by looking at the anion. I'm going to start the name of this. We know for sure it's going to be titanium, and then I'm going to put a parentheses. And I'll write the charge in that parentheses. Now, my anion here, you should recognize this. It's a polyatomic, is carbonate. And I know carbonate carries a -2 charge, okay? And because I have 2 carbonates on my negative side, both carbonates being a -2, I have a total of -4. Well, I know this side plus my -4 has to add up to 0 to be a charge-neutral compound overall, and since I just have one titanium, I know this is a +4. Okay, so because it's a +4, I'll indicate that with Roman numerals, and then I'll say carbonate. So titanium 4 carbonate. And then lastly, we have potassium 3. Sorry, guys, I must be brain dead today. We have K3P, okay? And so potassium is our cation, and it's a main group cation, so I don't need any Roman numerals, so I'm just going to write potassium. And then I just need to name my anion. If these are main group atoms or elements, if these are main group elements in your compound, you just name them together. And you don't include the charges when you write the name. You don't write the word ion in, so it'll just be potassium. And then this is phosphorus, so as an anion, it will be phosphide. If some of you wrote phosphate, that's because you're thinking about PO4, and these are not the same, okay? This top one is phosphide, and this one is phosphate. So potassium phosphide, no Roman numerals. That would be the name of these. I hope this was helpful. The only other thing to consider is when you have a transition metal that does have a subscript on it. So for example, let's do Cr3PO42, okay? These are a little more challenging because you're going to add up the total number on the anion side and think about the total number on the cation side that will match that, but then you have to divide that number by your subscript to get the charge. So try this one, and if you have questions about it, ask me after lab or ask me in class, and I would be happy to talk about it.